Got a question here about transformation of functions. It uses two trig functions which have been manipulated with respect to each other, and they've asked us several questions about that relationship. Let's have a look at it. So first of all, here's a reminder of sin x and cos x before they've been transformed. Sin x starts at 0 at 0 degrees, rises to gain a value of 1 by 90, falls again to 0 at 180, comes back through -1 at 270, and heads to 0 back again at 360 degrees. The point is it repeats every 360 degrees. So the next point it comes up from below to hit the axis will be 720. Cos x also goes between 1 and -1, but starts at 1 and falls to 0 at 90, and then continues on in a similar way, but is -1 at 180 and comes back to 1 at 360. It also repeats every 360 degrees. So the next time it approaches 1 from below will be again 720. So let's see what they've done to these graphs to plot the graphs in the question. Well, here is their version of sin x. It goes from 0 at 0 degrees, so it's not been shifted horizontally, but instead of going to just 1, it's gone up to 2. So we've multiplied every number on the graph by 2. The 1 becomes 2, the 0, of course, multiplied by 2 remains 0. So it's a fairly easy conclusion to the fact that A must be 2. We've got double the amplitude of what we started with. Now, what's happened to the cos graph? Here's their version. It starts at 0, which ours doesn't, and falls to -2, and ours only falls to -1. And I think you can see they've just pulled the graph down by 1. If I pull this graph down, starts at 1, goes down to -2, then comes back up to 0 at 360 degrees. We have a new function y is equal to cos x, which is the original graph, plus b. Well, plus b will be -1 because we've pulled the graph down. So I can say that b must equal -1. And those are your two answers for part A. They were both vertical transformations because the adjustment is well away from adjusting x in the equation. And I think vertical transformations are really quite intuitive and obvious. Let's have a look at part B. Use the graphs to find the values of x in the range of that to 720, the values of x, where the two lines, and it's their two curves, meet. Well, one meeting point is clearly this point. Another meeting point will be 0, and another meeting point will be 360. Notice by these inequality signs, they're including the 0 and 720, so we've got 3 meeting points already. So I can say, using our values for A and B, I can say that 2 sin x equals cos x minus 1 at, well, let's have a look at our 3 meeting points already. First of all, 0 degrees. The second point here, it's looking roughly in between 180 and 270. There are 90 degrees in between these two, so I'm going to say this is halfway. The grid's not fantastic, especially on this video plot. It might be more obvious on the printed paper, but I'm going to guess this is 180 plus 45, which is 225. The next meeting point will be 360. These graphs obviously continue on, and as I said, they repeat every 360 degrees. This point here will occur again another 360 degrees further on. So if we just add 360 to our answer here, we will get the next meeting point. And this will be at 585 degrees. And again, the last meeting point will be this point here, which is 360 plus 360. So this is 720. And those should be your answers for part B. Now let's have a look at part C. Use the graphs again to find the value of the sine curve minus the cosine curve, again it's exactly the shapes they've got, when x is equal to 450. Now again, using that same argument that everything repeats every 360 degrees, if I find out what happens to the graphs when x is equal to 450 minus 360, that will be the same result. So what is 450? Take away 360. It's 90 degrees. And this is the sine graph, and this is the cosine graph. So we're taking away the lower line from the upper line. So I can say at 450 and 90 degrees, 2 sine x minus cos x minus 1 equals, well, sine x at that point is 2, and the value of cosine x at 90 is -1. Taking that bracket away, this will turn positive, so our answer will be 3. And it's confirmed by the graph 1, 2, 3. So that's your answer for part C.